Alright, in this video we're going to begin section 14.4, which is triple integrals. Alright, so until now, we have integrated a function f of xy over a planar region R. Now, the region over which we will integrate will be a three-dimensional solid D, and our integrand will be a function f of xyz of three variables. Alright, so there are actually, when we did double integrals, we had type 1 and type 2 function, type 1 and type 2 region, So for triple integrals, there are 6 different types of regions. I'm not going to go over all 6 of the types. I'll go over one type, and then I'll make sure I do an example that actually has, I think, 3 different types in that one example, and I'll do it 3 different ways. But if you understand the type 1 and type 2 regions from double integrals, it will help understand quite a bit the types of regions we have for triple integrals. So first one is type Arabic numeral 1, Roman numeral 1. This Roman numeral 1 is what we're already familiar with. So this is a type of region in the xy plane where we go from function to function in the y direction. This is the new part of that. So now we're combining these two things. So consider the three-dimensional solid region three-dimensional solid region. Now this is going to be kind of long. Let's see if I don't think I can fit this on one line. D equals the set of points x comma y comma z such that x is between a and b, so x goes from constant to constant. Y is between g sub 1 of x and g sub 2 of x, and y goes from function to function. You all are familiar with that from double integrals. That is a type 1 region, type Roman numeral 1 region from double integrals. Now what we're going to do is we're going to tack on what z varies between. Now z is going to vary between x was constant to constant, y was function to function, but they're functions of one variable. Z is going to vary from function to function where they're functions of 2 variables. So f sub 1 of xy, so z is between f sub 1 of xy and f sub 2 of of xy. And then we'll close our little set bracket over there. So this is what a type 1,1 region is. So now how do we set up an integral if our region is a solid that looks like this? And I'll sketch a region like this so you have more of an idea of what it is we're doing. So if f is continuous on D. Now some of these, because you all know it's a double integral, some aspects I'm kind of taking for granted. Like we know constant's going to have to go in our outside integral, and it's going to go in this order in function of one variable. And then now on the very inside integral is going to be function of three variables. So now we're call this the triple integral over D of f of x, y, z. So when we are doing a double integral, it's dA with respect to area. Triple integral is dV with respect to volume equals the iterated integral. Constants go on the outside, a to b. Function of one variable is next. So g sub 1 of x to g sub 2 of x. Function of two variables has to go on the inside. F sub 1 of xy to f sub 2 of xy. So notice if you had been writing your regions down for functions of two variables, then it makes it kind of easy to, for double integrals, it makes it kind of easy to transition to doing this, setting up your integral for a triple integral. Our integrand is still f of x, y, z. These are z's right here, so it's going to be dz first. These are y's, so that's dy. And then these are x's, so that's dx. All right, so that's what that would look like for this type of region. Now let's kind of get an idea of what this type of region looks like, and then that'll give us a little bit of insight into what other types of regions, how other types of regions may look. So let's set up some coordinate axes. I'm going to make this kind of big because there are going to be quite a few details to our picture. Which is why I'm only going to do one of these, because I don't want to spend all of our time drawing. I want to do some examples. All right, so we're going to sketch some three-dimensional solid D. And it doesn't matter a whole lot what you sketch. So whatever, I have this thing. Whatever, some odd shaped sponge, for instance. All right, so they say this is our three-dimensional solid D, so I'm just putting these little lines on here to kind of indicate that these sides are all filled in. So this would be D. All right, now what we want to look at is we're looking at this region D and writing it in that set form that we wrote. We're not going to write it, but we're looking at this in relation to what we have up here. So we're going to take this region D and we're going to project it down into the XY plane. So then we can see why this is, look at this as a type Roman numeral 1 in the XY plane region. So the projection is where that comes from. So we project this thing down, and don't worry about if this doesn't turn out pretty. That's not a big deal. Now, type Roman numeral 1 goes from constant to constant in the x direction. So I know I want a straight line right here. So that's just pretending that this side right here that's closest to us of this thing, if we look at it from above, is completely flat. So then the other side as well would need to be completely flat because we go from function to function. I mean, from constant to constant in the x direction. So we're taking this thing and we're just smashing it down into the xy plane. Now, this side over here, we smash it down, just say it looks, I don't know, whatever, something like that. And this left side, we smash this thing down into the xy plane, whatever, it looks something like that, for instance. Where now we have this x goes from this constant a to this constant b. So we would say this is right here is x equals a. And it comes down to, let's just put it, I don't want us to get too messy. So x equals b, or you make your dotted line go all the way right there and just put a hash mark for b on the x-axis if you want to. And same thing up there. You could have put a hash mark up there on the x-axis. So now notice this goes from function to function in the y direction. So we'll draw our arrow in there as we usually would. And the bottom function would be this curve right here. That would be y equals g sub 1 of x. And then this curve up here is y equals g sub 2 of x. All right, so that aspect, oops, sorry, I'm going too far. So that dealt with this and this, which we're familiar with, that being a type 1 region. So we just took our thing, smashed it down into the xy plane, and looked to see what do we have in the xy plane when we do that. So that's going to depend on what your region D is. You could project it down into the xy plane and get a type 2 region down there in the xy plane. So that automatically gives us, with the Arabic numeral 1, we could have type Arabic numeral 1 with Roman numeral 1, or type Arabic numeral 1 with Roman numeral 2. The Arabic part is the fact that z is what's a function of x and y. So later on we could have that x is a function of 2 variables or y is a function of 2 variables. So now let's represent that part in our picture. We're missing that. This up here, this top part of our region is z equals f sub, so the top one is f sub 2. That one. So f sub 2 of xy. And this bottom part of our region, let me do this, let's say, we'll just put an arrow kind of there. I'm not pointing at the side, we're pointing at the bottom. That is z equals f sub 1 of xy. So now I'm going to kind of use this picture to briefly explain what the 5 other types are. So say for instance, one other type is we project this thing down into the xy plane and we end up, if it were different than this one, of course, this one, if those are functions and if that's a function, that's a function, it can't switch to being constant there, and then function here. But we're just going to reimagine our region D. So if our region D were a region that we projected down into the xy plane and it were function to function in the x direction and constant to constant in the y direction, that's another option. Then another option is we could take our region D and instead of projecting in the xy plane, we could push it back or push it left. So let's talk about pushing it left. We take our region D, and instead of pushing it down here, we project it left and we have some region over here in the xz plane. And then we look at that and we look, is that type 1 or a type 2 region? The convention is for type 1 is we would be going, because now we're working with X and Z instead of X and Y. The type 1 would go from function to function in the Z direction over there. Type 2 would go from function to function in the X direction. So that's an alternative. We take this thing, project it over here to the XZ plane instead. Or we could take this thing and project it back into the YZ plane. No matter which plane you project into, you have two options. So we project down here, it could be type 1 or type 2. We project left, it could be type 1. And when I say 1 or 2, now I'm talking about Arabic 1 or 2. Or we could project back and it could be type 1 or 2, Arabic 1 or 2. So that's how we get the 6 different types of regions. But I don't want to spend time writing out the integral for all 6 of them. But what I'll do is make sure that I point them out as we go through some examples. So I'm going to stop this video here, and then on the next video, I'll start doing some examples from the section.